Good morning, all. We're going to get started in 1 minute here. I will quickly introduce David, Bryan, and Naveed. And they're going to be discussing one of my favorite topics, but part of it, when I was reading their notes, involves detecting an attacker along the kill chain with speed, automation, agility, and adaptive. They hit all the key buzzwords for me. I think the only one they missed in there was blockchain, but we're heading in the right direction. David is a software engineer at Microsoft for 19 years. Bryan is also a software engineer. And Naveed is a principal software engineer. So let's listen to what they have to say. And at the end of the morning sessions, you guys will get a survey. There is a promise for an Xbox in the survey, and it is not a phishing email. This one is real. There is an Xbox involved. So please do those surveys, and thank you very much. I'll get out of the way now. Take it away, guys.
Thank you. Last year, commercial cloud revenue for Microsoft was over nearly $7 billion. We have the majority of Fortune 500 companies around the globe are using Office 365. My daughter started going to university last year. She's using Office 365 at university. My dad is an Office 365 user. One of the things all of our customers have in common is that they're expecting us to deliver world-class services in the cloud and to protect their data. So we're doing that in an environment now where attackers are achieving their objectives in minutes, whereas we're still taking, in the industry, hours, days, weeks, months to actually detect compromise. So at Office 365, we decided to build a system to try and help us address some of the challenges that we have in this environment. So today, we're going to talk about that system. We call it Vanquish. It protects our Office 365 data center assets. We're going to tell you about how we design agility into Vanquish, how we get agility by measuring everything, and then how we use machine learning to keep that agility at the speed of attackers. We're going to tell you some examples from a pen test we ran last October called Red October. Some of those lessons felt very good. Some of those were painful. So we'll tell you about that. So without any further ado, we'll have Bryan come up and tell you more about what exactly is Vanquish.
Hey, folks. So what is Vanquish? Vanquish is the system, as David said, we built in Office 365 to do detection, remediation, and alerting at scale in our data centers. So this is data centers like data centers for Exchange, data centers for Azure, so the whole Office platform. How do we do this? So we built detections by integrating a lot of telemetry from hosts, by building integrated context. So things like, is a deployment happening? Who's authorized to be on the system? Who took this action and were they on call at the time? We generate detections across the kind of gamut of what we could build. These include things like anomaly detections, unsupervised machine learning, supervised machine learning, red line detections, where we say, hey, we never expect a particular action to take place on a given service, and we know that this action is potentially malicious, so therefore we want an alert immediately when this happens. One of the things we've kind of built over the last several years is another system to do remediation at scale. And so we're going to cover how we do remediation, both automatic remediation in cases where we're not concerned about attacker scope, and automated remediation with a security analyst in the loop, where we're concerned about generating scope and remediating at scale all at once. And then we obviously build on the alerting platforms available to Office and to Microsoft. So we alert and generate paging alerts to the end user of the security system, in this case our team and other teams that we're protecting. So what do? We collect and process data. So that's the 90% of what we do is collect and process data. So we have telemetry coming off the box associated with Windows events. We've then gone and added additional telemetry the ODSP Protect team has built a product called HostIDS. We take telemetry from that, which includes things like network telemetry, additional process telemetry, WMI telemetry, and other pieces. And we integrate that with the Windows events. We build context by using the inventory data, deployment data, user data, and then we also take application data. So for example, who asked for a JIT account on a given system? What did they ask for? Who approved it, and when was it approved, and how long should it be good for? And then we also integrate other components, like Defender, like AppLocker. We take all that data, and we process this in Spark and Kafka. We process it, and we say, hey, how can we slice and dice the data to get a small, limited set of actionable alerts that we can go and take some concrete action against an attacker? And so kind of throughout the presentation, we're going to tell you how we've done this and why agility really matters when you go and build a detection system. There's lots of folks building detection systems, and our key point here is when you go and build these, when you go and improve your detection system, agility should be a key concern. So how have we built agility into the design of the system? So we've got kind of a few points here. Move fast and don't impact customers. We argue that you should treat detections as code and not scripts, and I'll give you a few examples there. Obviously leverage the right technologies and make sure that your detections move with the speed of attackers. Right? We know that attackers can compromise systems in minutes, so your detection, alerting, and remediation platform should move at that same speed. So first, how do we move fast without impacting customers? Substantially, Vanquish is decoupled from monitored assets. Now, when we're rolling out new telemetry generation, that's not true. When you've got a service like Office 365, you rely on that service to be available. And so when you go and do deployments to that system, you go through a ringed deployment process. You have to cross your T's and dot your I's. You've got to make sure that you've got all of your systems up and monitored. You can't deploy them all at once, and it takes days or weeks to deploy across the entire gamut of the systems. So what we've done is we said, hey, telemetry generation we'll go ahead and deploy in this kind of slow ring deployment fashion. But for all the detection logic and detection processing, we want to be able to deploy that separate from our production assets. So this is deployed in the cloud as a separate production asset, and we can deploy to that immediately. And we do, multiple times a day. You're able to apply filters across all the dimensions, across all detections in seconds. So once you've isolated that a particular person is using a given source as a C2, for example, or they're using a given process or using a given TTP, you can go and add a filter or add an IOC across the entire set of systems you own in seconds. Kind of the next point we're making is that detections are code and not scripts. So several years ago, we ran all our detections on Cosmos. And this was great. Cosmos is a big data processing platform to Microsoft, and we like it. But what we found was that when you're running things as scripts and not code, what you see is you've got some normalization process, for example, and then you've got a follow-on process that does something else, and a follow-on process that does something else. And anything that is broken along the chain could potentially break your output. And so when we moved to code, what we basically said was, hey, let's build detections as code. Let's build in unit tests and acceptance tests to the detections themselves. This gives you kind of three big pieces. One, if I go and build a detection that's built on top of some normalization, and my detection rolls that into production, and I'm getting good, sound detections out of it, and then David comes in and says, hey, I think that the normalization logic needs an update, and I'm going to go change that. How do you know that his normalization logic didn't break my detection? Unit tests. And that way his normalization change can't get into production and break my scenario. Likewise, some other examples. Detections where you're looking for a specific actionable item, and you want to say, hey, I'm sure I can find this particular thing. You can actually take the raw input data and run it all the way through a unit test and validate that you will get this out and that it will generate alerts because you've got the full ability to do unit testing here. The next big point we've got is kind of leverage the best of Microsoft and open source technologies. So we use a lot of great Microsoft technologies here. Microsoft Siphon, Azure Cosmos DB, Microsoft SQL, Azure SQL, and Kusto. And there's lots of other kind of technologies we leverage in the Microsoft stack as well. But there are open source technologies like Spark and Kafka that we've found have given us great ability to leverage and scale our detections. And leveraging the best of these technologies allows us to leverage open source contributions to these platforms and make sure we're kind of at the tip of the spear when it comes to generating good security detections. So, detections at the speed of attackers. In the hunt for Red October, David said, hey, we've got a pen test. So to provide a little bit of context for that, the pen test team broke into Exchange, and we alerted in 4 minutes after their intrusion. That's great. So in the Verizon slide David showed earlier, attackers were able to compromise the system within minutes, check. We were also able to detect them within minutes. We were able to add IOCs within minutes. So what this means is we saw the red team and we said, hey, they're using these few servers as command and control. They're using these particular TTPs, and we could go and add IOCs for these TTPs in minutes across the entire ecosystem that we own. We were able to then do some forensic analysis, go and get the malware they've got, and do forensic analysis and generate a new detection for a new thing that we'd never seen before in a matter of hours. And we were able to deploy this to the system, add that to our ML system, and find the pen test on systems that we had not seen them on previously. So we were able to take a total unknown, an unknown unknown, and go and build new detections around that and come up with success while the pen test was ongoing in a matter of hours. We then went to remediate. And frankly, we were a little bit too slow. So we started to try to remediate. The attacker pivoted between systems as we were going to continue to remediate. And while we got detections in most cases, in some cases we didn't. We completed remediation, but the Agile attacker was able to continue to evade our attempts to completely remediate and pull them out of the system. So what did we do? We took that as a lesson. And we said, hey, what can we do? We started with the same thing that we've already talked about, on-host telemetry and cloud-based detection. So the detections we just talked about at speed, and we said, hey, what can we do? We'll build a remediation subsystem. And this system will allow us to say, hey, we want to go and remediate at scale across the entire ecosystem for this particular set of TTPs that we're showing. We then used the data center management service, which is a part of our tooling for automation, to reach out to each of the hosts and execute that remediation action. So next, David is going to present agility through measurability.
All right. So we like to measure stuff because it keeps us accountable for what we're doing. So there's 3 key things that we like to measure. One, fairly obvious, is the system up? Can't catch bad guys if your system is down. Then kind of the second piece is, are we covering all of our endpoints? So are our endpoints covered? Are we getting telemetry from them? And then lastly is like, are we doing what our mission is? And that's detect badness. Are we actually successfully catching things? All right, so let's talk about system up first. So we run our system like a service. We don't run it like an application. So that means we get to leverage all the knowledge and experience that we have here at Microsoft at running large-scale services and meeting SLAs. So we have on calls, we can page, we have all those kinds of things that allow us to be confident that our system is up. Some key things that we look at, that might be a little different, is latency for the data that we're receiving in is a really key factor for us. So we like to be very attuned to what's happening with our data. Also that it's complete. The other key thing is at the nucleus of Vanquish is Spark processing. So when we see that streaming data, it's being processed by jobs inside Spark. And so we need to keep a key eye on those jobs. So we have a lot of metrics that help us understand if those jobs are healthy, and they'll alert us if they're not. Okay, the system's up. The next piece, are your endpoints covered? You need to manage your fleet and make sure that all of your fleet is protected. So some of the things that we do is we look for heartbeats from HostIDS, and we also look to make sure that it's configured correctly and sending us the events that we expect to get. The other thing is we have specific detections for tampering with that HostIDS process. So that makes, if attackers try and disrupt, we should get signal. And then, of course, one way that we stay agile is if we do detect an unhealthy endpoint, we have automatic remediation that will go and reinstall the service and make sure that we're covered. Now, you may have been asking yourself earlier when Bryan was talking about how we were too slow in remediation, if you guys are so good at detection, and you say you're good at detection, why didn't you detect when the attackers pivoted? We missed some endpoints. Vanquish wasn't getting signal from those endpoints. That was a lesson we know. So we spent some more time recently trying to address not having full coverage on all endpoints. The graph that you see kind of on the right here it's a stat graph. Green is where we're receiving endpoints that are uploading their data, kind of where we expect it, which is under 7 minutes. Yellow is under 15, and you'll see an occasional red dot up here. That's when we're seeing data coming in more than 15 minutes late. When that happens, we have to go take action and really understand why is that data taking so long to get to us. On the right, this is kind of, you see these caverns and that sort of thing in this graph. This is the 99th percentile. So we're a service, so machines are constantly getting upgraded, they're getting patched, they have to get flattened to receive new bits, so they're coming in and out of the service. So we never want to see 100% completeness in our metrics. There will always be some machines that are changing state. So when we took that, we really took the lesson about endpoints. So it says 99th percentile, but for Exchange, that's now 99.9 percentile. Okay, so the other thing that we want to measure. Are we detecting badness? Are we catching attackers? And there's kind of two ways that we go about validating that we're catching attackers. One is pen test, and then the other is some software that was built by the M365 red team called AttackBot. So let's talk about pen test first. Over the past year, every pen test where Vanquish was installed across multiple services, we received paging alerts to their presence. We had 0 misses. So we're pretty proud of that. We think that's a pretty good metric about how well Vanquish is doing at catching attackers. Now, we weren't always able to actually keep the pen test team from meeting their objectives. So our pen test team is awesome. It's not, we didn't catch them because they were making mistakes. We caught them because we're good, and they were able to achieve their objectives because they're good. And they're continuing to teach us lessons about our systems. M365, we take an assume breach philosophy. An attacker with unlimited resources and unlimited time is going to breach your system. You need to be prepared for that. Okay, pen tests are expensive. They usually take a few weeks. Dedicated resources are involved. You can't have a pen test running every day. So our red team did something for us. It was fantastic. They built this software called AttackBot. AttackBot is wonderful. Oh, that's kind of funny. Sorry, my slides are a little funny here. Oh, all right. So what AttackBot does, it runs real attacks. They're not injected data. They're not synthetic. They're real attacks. They take actions that would happen during a real attack, and they run that real attack on randomly selected hosts, randomly selected scenarios. Those run, Vanquish processes a signal. We create our detections. We auto-label those detections as AttackBot because we have knowledge of AttackBot and what it's running. So we label our detections as running, excuse me, we label those detections as AttackBot. That allows us to measure our results. So we can actually say, here's a metric for whether we're catching the badness or not. And if we don't catch it, we can adjust, and we can do it again. We are running attacks against Office 365 across multiple services every day, multiple times. And we're validating that our detections work. We're not telling you that our detections work. We're proving to you our detections work. So here is, we have lots of these. This is just kind of just an example so you get the point. Color, good. Gray, bad. This was detection for tampering with HostIDS. You can see when we first rolled it out, it took us a little while to get it perfect. And things were going good. We had a mistake. We were able to fix it. We're back to healthy. The bottom chart is more of an all-up of all our detections. And this is, it's a little bit complicated, but this is where an attack is run, and we received some signal that the attack was run. And you can see we've had dips, we make corrections, and then we go. So by measuring, it allows us to have confidence that what we're doing is working. And we're not just relying on, hey, we think this works. Okay, so to sum up, system up, protect your endpoints, and make sure you're detecting the badness. Okay, so Naveed is going to talk about how we use machine learning.
Thank you, David. So, when you are protecting an asset which is generating close to 7 billion annually, which customers love and trust, that we're going to keep their data safe, and we're just running on hundreds and thousands of machines, when you want to protect it, you have to do it carefully and you have to do it intelligently. Duh. But what I really mean by carefully here is that you want to explore all the aspects in which attacker might attack your service, right? Which translates into lots and lots of detections. And when those detections are running on hundreds and thousands of machines, it is going to generate huge number of traces that you will have to sift through to find attackers in there. Right? So you have to build automation in your triage process or assessing or your process through which you find attackers. And you have to build intelligence in there. So when it comes to looking at the traces and deciding what trace I should use for firing a detection and what trace I should not use for firing a detection because it may be a false positive, what people generally do is they diligently try to learn what is the normal behavior of your service under normal circumstances, and they create whitelists for it, and they create filter rules for it. It works beautifully for a static service, not for Office 365. Office 365 has teams in Redmond, Cambridge, Europe, China, India. Sun actually never sets on Office 365. And these developers are really good developers. They are crunching code like crazy, and you know what? They deploy like crazy. And when they do that, the service very quickly changes, and all those whitelists and all those filter rules are obsolete, and benign noise starts pouring in like raindrops in millions. So there's an opportunity here to learn all of those rules. Same software running on hundreds and thousands of machines, doing the same thing, is going to produce the same kind of traces. And all of those are going to fall into this normal. And the thing about attackers is that when they are targeting something specific to exfiltrate, they are going to appear on few machines. And even if they are targeting to bring down your service before they get to all the machines, they are going to start on few machines. So they are going to appear in this long tail. And hence, so this is our anomaly detection. All the normal comes here that you can safely ignore, and then you can focus on the long tail. There are some challenges to this. And everything which is in the long tail is not necessarily malicious. There are legit things that the service does and doesn't do as often. So they show up here. And also, as the deployment is rolling down to the machines, when they roll onto one or few machines, then they show up here. So noise creeps up here. So still, like anomaly detection is super useful because it can reduce the number of traces that you really need to look at considerably. 500 billion to close to like 100,000. And now still a lot of traces, right? A lot of detections to triage. There's still an opportunity here, and the opportunity is in the human behavior, right? For an attacker, if something has been successful in the past, they are going to try to do it again, right? Why wouldn't they? This has worked. This has worked for company A. It might work for company B, so they are going to try. And also, there's a big community of hackers. They're sharing their libraries, they're sharing their tools, and those signatures do show up. And we have seen it with our pen testers. We have seen it out there in the industry. So we can at least learn something that we already know about. Hence, we apply machine learning to it. That greatly reduces the number of things that we need to look at. And so we generate 1 to 5 alerts per day, which are very similar to the non-attack behavior, as well as we generate alerts on when our pen testers are active in there. So in order to use supervised machine learning, we maintain examples of our past pen tests, and our triage analysts, whenever they label something bad, we maintain that also. Then we train a model. We subject the new activity in the data center, and the model tells us it is interesting or looks something malicious, and we need to look at it or not. But we are still not out of the woods yet. Number one thing, there's limitation. What you don't know, you cannot learn using supervised machine learning. But if you have an awesome pen test team, which we do, they probe your service in so many different ways, so you can really auto-learn a lot. And also, we use some of the proprietary techniques. We create synthetic examples to expand our horizon on which we are learning. And there's a talk tomorrow about that, 3 p.m. I hope you join us for that. We'll dig deeper into supervised machine learning there. The challenge there, again, is Office 365 service. Of course, it evolves quickly. And when you train a model, it becomes obsolete quickly. Similar problem, right? So anybody who has worked in machine learning or data science knows that it's a process. Like, you collect all your data, you normalize it, you sample it, you wrangle the data, you identify the features which matter or not matter, then you extract those features, you build your model, you build multiple models, figure out which one works best with this data, and then you put that model in production. But before you put that in production, you want to figure out what's the threshold that I want to use for this model. And when you are training a new model, you need to readjust the threshold. There's a lot involved there, and it takes time. And when service is changing quickly, you don't have that much time. So what you do is you automate this whole thing. And you automate this whole thing with the goal they should be able to adjust itself, run itself. So all those decisions that data scientists are making or pipeline engineers are making, you embed that kind of intelligence into this automation. Of course, you cannot embed everything, but most common decisions that we take, you can embed in that. So Red October. There were 24 machines that were compromised. Machine learning alerted on 10 of them a lot sooner than human got to know about them. 6 of the machines there was a tie, like machine learning alerted 15 minutes before human got to it. And there were 8 machines that had totally new behavior on which we had not trained our models. But based on what machine learning alerted on, we identified some of the IOCs, and based on that, human found 2 more machines. We created new detections in it, in the model, and the model quickly learned on it, and then alerted on the rest of the 6 machines which human had not found. And so we were able to do it because we had built a system where new features can be added to the model, like very, very boldly, without worrying about that it's going to break the model, it's going to break the code, because you don't really have to write the code. A human can insert a new feature, like using XML, or any other format, or any other syntax that you decide on. Or there can be another module, which is assessing the features, which is assessing the detections, and making the decision what new feature should be put in the model. And since this is a model which is going to be in training, it would be compared against the production model and would be promoted only if it does better. And there are so many gating mechanisms in there that we have built in this pipeline, which is going to decide what is the best model on the new data, on the coming data, on the recent data, not a 1-month-old data, that need to be promoted to production. So to sum everything up, there are researchers in academia in machine learning, and there are practitioners. And among practitioners, as my colleague Jeff, who works in machine learning with me, says that they are industry thought leaders. Microsoft is one of them. They have incredible talent. We have used that talent to build a machine learning pipeline where we have unsupervised model, where we have supervised model. We have fully automated it, and we have instilled intelligence in it. Right, I would like to invite David Hurley.
Okay, so we're just going to wrap up. It's a cliche, but it really is true. It takes a village to build a system like Vanquish. We didn't build every piece ourselves. These are some of the people who have helped us. That's our red team up there. You might recognize some of us in some of these pictures. I think Matt Swan's in there somewhere. But the point is, we don't rely on building everything ourselves. We take components from other teams and try and focus on the aspects of catching attackers and remediating. All right, so if you take anything away from the talk today, when you design your systems, design to move fast and not impact customers. When you have an incident and you're trying to catch an attacker, you may need to take some risks. They may be showing you new techniques that you haven't seen before. You don't want to impact your customers while you're trying to track those attackers. The other thing, build confidence in your system every day. Make sure that your detections are working, how you expect them to work. You don't want to find out after someone has compromised your system that your detections didn't work like you thought they did. Okay, and then as Naveed was just talking about, we want to be effective at scale, and we want to use intelligent, automated machine learning. You can't do it all by hand, right? So got to have the whole pipeline automated and leverage the power that machine learning has. All right, if you're an Office 365 service and you haven't onboarded with Vanquish, you should come talk to us, because there are some of you out there that aren't onboarded with us. Otherwise, thank you very much for your time, and we're here to take any questions.
I got two questions. Like how you communicate to end user or asset owner that there is a remediation process being initiated on their system when you auto detect that.
Right. So remember at the beginning, we talked. This is defending Office 365 data center assets. So if we're taking remediative action, we're taking it on Office 365 data center assets. We're not necessarily communicating with customers that, because their data could be in multiple places, we're defending our assets.
Okay, so my second question will probably give a clue why did I ask that. So what is adoption ratio from other security team that you have for this solution? Because I see other security team are still relying on human operation, and the chances of detecting either those threats or remediation is very long in terms of response time. Yeah.
So the question is, are there other teams that have onboarded onto Vanquish?
No, question is like Office 365 is one organization which is running a security operation. At the same time, within Microsoft, you have other teams like DSRE is there, and then you have CNE, and then OWDZ. So how open they are to adopt this solution in terms of
So
moving to
we're
this?
working with other teams to try to figure out how we can integrate with their systems. Teams like Scuba, teams like WDATP, we're in conversations right now on how we can integrate with them or how they can integrate with us. I don't think that they'll be adopting our solution. I think the key is to find kind kind of common ground where we can work together. Somebody over here?
You answered it already.
Okay.
Thank you.
In one of the slides, you showed a few numbers from 50 or 5 billion to 10,000 anomaly detection events. That's a big number for a day. I guess part of it is handled by automation. How much of it is not, and how do you tackle the case where you have too many incidents to manually go through? Did you face that situation? And what were your lessons learned?
So almost all of that is automated removal of noise at this point. So essentially what we're doing is computing multiple conditional probabilities and then kind of weighting them. And that has allowed us to get to that number. So the real piece where we're either manually tuning or using machine learning is going from that 10,000 a day number or 100,000 a day number down to the 5 or 2 or 3, right? So basically we've managed to automate away most of the input events automatically. Things like what process is connecting to what IPs, what process is connecting to what destination, what process is started by another process, where do we see threat injection, who uses WMI, and all that's automated way.
One thing I'd add to that is we still have all the information. We have all the detections that we created that we fed into the machine learning. And so if the OCE gets alerted and they respond, they'll see all the information that we have on that machine. So it's not like we don't just throw it away. It's there. But that way, you're not necessarily sifting through all of that data at first.
Right. And the last piece I'd add to that is, so you got this 500 billion input events, right? And you break that down to call it 100,000 anomaly detections. Then you break that further down into a handful of ML-based detections. And then we go and look at those. And so like David said, you've got the detections that you can go look at. We also do a number of, in order to build anomaly detections, you have to do counting. So we have the ability to go and look at those models to say hey, how frequently does this actually happen? For this service, for all services, right? For Azure services, or for non-Azure services. And that's really helpful when you're trying to either debug a problem or to determine if something is, very anomalous or very malicious, right? So.
Yeah. And also you don't want to tweak the anomaly, the normal line too much to the right, because it gives us useful information, what is happening in the data center. And we do go and hunt into it, because the machine learning pipeline is very, very accurate, doesn't give us many false positives, and always alerts on the attack whenever the pen testers are there. So instead of having 10, 15, 20 people just looking at the screen, it has allowed those 10, 15, 20 people to go and hunt for the attackers. And also allowed our machine learning engineers to work on other new challenges, new complex problems.
I just got a quick question on how you guys manage your alerting. Is that your service engineers log into the Vanquish system and monitor that, or do you cut bugs out to some type of VSTS repo? How do service engineers interact with the system?
Sure. So we're DevOps. So we get alerted through ICM. So that's Microsoft's internal alerting system. So we'll get various alerts. We might get email, some things page. And then we'll take action using that system. We're not necessarily cutting bugs into other systems with our alerting. Cool. Well, thank you. Go ahead. Yeah.
Yeah, thank you. So I have a question regarding the value prop with respect to our pre-existing other products about for example, the Office 365 ADPs or Defender ADP, which has some response capabilities. So if I just kind of discuss this to the customer, how would you kind of calibrate this, and what would be the value prop for Vanquish in that terms? I'm a Microsoft PFE, so by the way, yeah.
So keep in mind, right, this is protecting our internal data center assets. So this isn't something we can go and sell to a customer, right? But in terms of kind of how we differentiate ourselves from Defender, we don't. We're hoping to integrate with Defender. We're hoping to leverage things they build and to kind of build on top of that, to add new intelligence and add Office 365 specific detections and Office 365 specific information. Things like who's on call, is this token authorized by the Office Taurus deployment system, and so forth like that. So we don't think of ourselves as competitors. We think of ourselves as peers wanting to further integrate with other products.
So how is this different than Azure Security Pack?
So this is a little bit different than Azure Security Pack in the sense that kind of three things. One, the amount of telemetry we're generating is somewhat different. So for example, this is generating all network telemetry coming on and off the box, and I don't believe AzSecPack is doing that right now. Two, this is not differentiated entirely. We're working with AzSecPack to deploy our telemetry generating agent as a part of AzSecPack. So we're working with them to do that. The other kind of piece that is AzSecPack is you've got the kind of telemetry generation on the box, and then you've got the kind of cloud processing pipeline. And so right now we're effectively providing a secondary or different cloud processing pipeline. But we're also looking to consume detections out of the AzSecPack cloud processing pipeline. We want to provide a single pane of glass across all of Office, Azure assets, Pilotfish assets, bare metal assets, anything else we own, so that folks can monitor across all Office assets and get a single point of alerting and detection and response.
Just follow-up question. So is there like any plan to integrate with Geneva Monitoring Agent?
So the data is uploaded in many cases right now through Geneva, yes. In some cases it's uploaded through like the Office Data Loader. Basically, yes, we're already integrated in many places.
Okay, thanks.
This one here.
The HostIDS.
Oh, mic is coming.
Yeah.
The HostIDS that works on endpoints, is it something you developed, or is it some open source, or is it some commercial tool, or is it just Defender?
Yeah, so that's an internal Microsoft piece of software that was developed by the ODSP SharePoint team. And so that's an example of how we don't build everything ourselves. They built this. They now, I would say, curate the software, so it sits in their repo, but lots of teams contribute to it.
Hi, we've just started deploying Vanquish ourselves as part of moving to Geneva, Griffin, Taurus. But one of the things that keeps on coming up, similar to the Azure Security Pack, was why aren't we using kind of one for everything? Is it possible to deploy the two side by side at the moment? And then is there any performance difference on the machines? Because that's something else I've heard is that Vanquish is apparently less consuming of resources than the Azure Security Pack. And that's one of the reasons why the Office teams went with that, apparently.
So there's a couple of things there. One, right now, yes, you can go ahead and deploy both side by side. And one thing is you'll have two security monitoring agents running in the box, which is going to produce more telemetry. Two, so HostIDS in general is not any more or less kind of CPU conscious than AzSecPack. They've done a great deal of work, a great deal of good work to go and make sure that their platform stays well within bounds. And frankly, I think we're taking a few pages from their book. We do generate a little bit more telemetry. So like I said, the network was a good example, but there's a bunch of other telemetry as well, which kind of the key reason that we're asking people to go and install this is that additional telemetry has been highly leveraged in finding attackers in the system. And so that's part of why we're asking people to adopt that.
Cool.
Did I hit every point there?
It does, exactly. And it's because we had people working in the Azure team before, kind of knew Azure SecPack coming into Office and asking us what we're deploying, why we're deploying it differently. And we never had that kind of, this is the answer as to why we're doing it this way versus the other way. And hopefully that clears it up. I'll be talking to the Office team this week as well.
Okay.
To see if that bears out as well.
So if there's nothing else, thank you very much, and have a great day.
Thank you.